So here I'm going to make some data that I'm going to use later in my class. The main data set is actually some growth rate data for real GDP for a set of 4 countries. But right now I'm going to take some more or less original data and turn those into real GDP and turn those into growth rates. So it's kind of like a preliminary step. I'm going to walk through it. So this is for my Economics 346 at Northeastern Illinois University. It's the second lab in the class. And we're going to make the main growth rate data. Basically, we're going to start with the levels rather than the growth rate. So it's just, in nominal currency. The U.S. would be dollars, for example. And we're going to have nominal GDP, and then I'm going to use CPI as the deflator because that's better availability than like a GDP deflator. So I'm using nominal GDP and CPI. I've got 4 countries: Canada, Japan, the United Kingdom, and the U.S. And first I'm going to make real GDP, and then I'm going to make the growth rate. So I'm going to make it step by step. Sometimes I leave out stuff. If you know some R, you might say, why didn't you do something? It's because it takes time to learn those second and third and fourth things, but right now I'm going to be just doing the real basic stuff. Right, so I'm going to do some things a couple different ways, just to show you different ways of doing it. Also, these are actually time series data, and I actually work a lot with time series as an economist, but I'm actually not making time series right now. I'm just treating it as a matrix, essentially. So I'm doing this 2 different ways. One way to do it is you can, I've got my working directory here that I'm not going to use right now, but I'm going to actually load it. I've got this preloaded on my website, so I've got the URL here just to make it a little bit easier. And you can see here I've got 49 annual observations for 9 different variables. One of those is the year. And that's 4 countries, 4 nominal GDPs, 4 CPIs, right? So one thing you always do is you take the head, which is the first 5 observations, and you can see here that I've got CN is actually Canada, Japan, UK, US, and then the price levels are here. You could also take the tail for the bottom observations. If you type that in, I believe I end in 2017 because 2018 was not available for all data here, so you can see how it goes. All right. So first I'm going to do a couple different ways. I'm going to make CN, Canadian, real, Y for GDP, and it's always 100. Take these vectors. Now, because it's not time series, you can do it this way. Data, the dollar sign tells you which column to use. So it's CNY, which is nominal GDP, divided by the price level. If you run it, you get this over here. All right, so that would be in real, probably millions of dollars. All right, and then you've got Japan. You can do the same thing, but here I've got the position of the columns. Remember, it's all rows, comma, column 3, and then because it's 1, 2, 3 for the including the year, and then 7, 8, 9. All right, so you go 1, 2, 3, 4, 5, 6, 7, and so it's column 7, and you do that, and you get a second one over here. Now it's going to be much larger. You can see the e to the 08, that exponent that's 8 zeros following. It's because Japanese yen is a fairly small currency, so GDP in nominal in yen is going to be extremely big. All right, but that's correct. All right, and then another way to do it is you can attach the data so it knows whatever you're saying is talking about this data that we created. Remember, this is all 9 observations. And then I just put in the column names, UKY and UKP, and same for the US, I can make these. All right, so now I've got 4 real GDP series, and then I'm going to detach the data. Right, so these are just individual variables. They're not really grouped in any kind of a set. So I'm going to make something called RY. That's the name of my object. And this is going to be a column binding, basically binding the columns. Data 1, I'm keeping the year, and then the 4 things that I created here, I create that. Now I've got a set called RY, and you can see it starts in 1969. It's got all 4 variables. All right, so we made GDP, or took nominal GDP and CPI, turned it into real GDP from 1969 to 2017. All right, now we're going to do percentage changes. Now, I use log differences, and that's used in economics and finance all the time. This is the natural log. It is not log 10, and I'm going to make a 2-step process where I make the natural log, and then the log difference is the equivalent of percentage changes. All right, so this is actually a multi-step calculation because I take the log first, and then within that, right, so this is one thing, there's another set of parentheses around it. This is the difference, right? So that's how R would call the difference. And then to make it like an annual percentage, always times 100. And then I've got growth. And if I do this, take the head, it's going to look like this. All right. Now, this is percentage changes. You can imagine that 5% growth in the 70s was probably pretty good for the U.S., the U.K. or any other country. Some boom times, some recession times, etc. So this is the 70s stagflation starts down here. But notice here, this is all the same because the difference in growth of a year is just one. Every year is 1 year later. But if you take it in logs, it's going to be this number here. So I'm going to replace it. Well, we're going to notice that growth, because you lose a year, right? The first year, 1969, has no growth rate. The only 1970 could be the first observation, because it's growth from 69 to 70. If there's no 1968, you can't have it. So growth, you're going to find out that if you just replace the year directly, it's not going to work. I'll show you the error message, but then we're going to drop the first observation of the year, and how you drop an observation is you put a negative sign, and you put the position of it as the first row. Okay, so here I'm going to replace growth. This is my object that has all the growth series in it with a useless year column, and I'm going to first try to call it data 1. So this is basically saying first column of growth replace it with first column of data. It should be this right here. It's not going to work. All right, so this is the error message. It comes in red in RStudio, and it says number of items to replace is not a multiple of replacement length, right? Now, if you have 20 observations, you could replace it with 10 observations, or just start repeating it. But if it's 21 observations and you put 20 in, it's actually not going to compute, right? In Excel and some other software, it'll just kind of start repeating 1 or 2. This will actually just not compute it at all. So here I'm going to say, well, replace with data, but this first row, what's the opposite of something is nothing? We're going to say negative. This means drop it. So negative values are saying drop this thing, and the thing is the object in row 1, the first row, all right? And this is column 1. All right, so drop the first row of column 1 in data. All right, it's going to be 1 length shorter, one year shorter, and then put that in growth, in the first growth. All right, so column 1 of growth becomes this shortened data column. All right, now let's look at the column names. Right, so this is the function for column names. You can do this for row names too. This says return me all the column names for growth, and these are the names we just had, but because we replaced it, notice up here it was never here. This is saying there's nothing in here. There's nothing in these quotes. So I'm going to give it a name. I'm going to say take column names growth, not all of them, just the first item. Right, so this is the thing in brackets, and call it year. All right, run that, and then show me the head of growth again, and now I've got year in here as well. All right, so now we have a nice group. Here's a matrix, right? It's not a data frame actually, but it is a matrix of growth rates for these 4 countries. Then we're going to write it to a CSV file. Notice I set my directory above, and this is the thing, write CSV. This is the column. Now it's not write CSV2, which I believe works better for some European data. Write.csv, and you have to say, well, what do you write, and what do you call it? All right, and so you're going to take growth, and we're going to call it growth.csv. All right, and that's going to go to the directory I selected. All right, and then now that should be in the folder that I have. All right, so what did we do? We started out, I've got some provided data where I took some international financial statistics data, put it on my website, we pulled it up, took 4 countries' CPIs and nominal GDPs. We made real GDP using some formulas, made some different variables, some different ways. Then we took log changes to make growth rates, and then made a group of those, did a little manipulation to add the year columns, and then I kind of showed you how to use the row and column notation to drop a value. And then once we had all those new real GDP values and we made real GDP growth rates, we put them in a set called growth and we exported it. And that's going to be the basis for the next thing that we do.